This video focuses on function notation, mapping, and vertical line test. This first example is just a description of what a mapping function looks like. So you have two boxes. You have set A and set B, and they have different domains. So set A in the blue has the values 1, 2, 3, and 4 listed in these circles. And they are mapped to 4 circles that are in domain B and set B. So you'll notice this first circle, 1, maps to 0. So we list that as an ordered pair, 1, 0. Then our second value, 2, maps to -1. So that's an ordered pair, 2, -1. Then our next circle, 3, maps to 5. So that's an ordered pair, 3, 5. And then our last circle in the domain maps to 9. So that is 4, 9. If you read on your own the characteristics of a function on page 27, these 4 ordered pairs are creating a relation and a function. So please make sure you check out page 27 in a pre-calculus textbook. This is a different description of a function. You have your domain, which is your independent variable, and it goes into the function, and what you get out of the function is the range, which is the dependent variable. So imagine taking a 2 and substituting into the function, so it's going to go right in for x. So you say 2 plus 4, and what you get out is 6. And then you would do the same thing for 3. Substitute 3 in for x. Well, 3 plus 4 is 7. What you get out is 7. So you'd start being able to list some ordered pairs. 2, 6 is one ordered pair. And the next ordered pair is 3, 7, etc. So we have our function notation x and then f of x. Here's a couple examples, and we want to check and see, do these ordered pairs pass the vertical line test? So remember those characteristics on page 27. Do we get 1 point going through each imaginary vertical line? So let's take care of example A. We want to graph these ordered pairs over here. I'm just going to make this a little bit smaller here. All right. So over 2 up 3, over 3 up 1, over 5, down 6, over 6, up 4. So there's our 4 ordered pairs. And what we're going to do is we are going to create vertical lines. It touches once here, touches once there, touches once there, and once there. So we say these 4 ordered pairs, which are relation, also pass the vertical line test. So we'd say this is a function. Now it's the same thing with this second example. Make this a little bit smaller too. So over 3, down 1, over 4, up 5, over 5, up 2, and then over 5, up 0. When we create these imaginary vertical lines, an issue pops up with these 2 ordered pairs. They both touch on the same line. For it to pass the vertical line test, it must only hit once. So this fails the vertical line test, so it's not a function. Now here's 2 examples where we have now relations that are these continuous graphs. This looks like a shape of a V. If we imagine creating these vertical lines through here, hits once, 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 once. So yes, this passes the vertical line test. So it is a function. In example D, this is also the shape of a V, but if we create a vertical line through this purple piece, it touches here and there. It touches twice on that imaginary vertical line. So it fails the VLT, so it's not a function.